The blue and yellow vectors shown are the ACS. You can see it in all the views, including front view and top view. You can access the auxiliary coordinate tool from the primary toolbar. Those are the various options for manipulating the ACS. And this is the list of predefined ACS where you can add more ACS and have them saved in this list. To have an ACS saved in the list, you need to create a new ACS and define a name for it. You can always change the coordinates of the ACS origin manually by defining it here. For example, I will set the origin of the ACS to 20 feet in the Z direction. To have the ACS actually active in the model, you need to activate it either in the active view or all the other views. Now, as you see, the ACS has moved up by 20 feet. This ACS will always be active until you revert back to the base ACS. Like any object, you can delete any ACS from the list or copy it to define a new ACS. One of the options to define new ACS is to define an ACS by face. This tool works by selecting an element's face to act as the new working plane. As shown, the ACS has been updated in the view to be an inclined ACS parallel to the top flange of one of the inclined beams. This ACS is temporarily active in this view only. To save it and make it active in all views as well, you need to either create a new one or select existing one and select Update from Active. To have the properties of the new ACS override this one. Also select the ACS and select Set Active in all views. You don't have to create a new ACS each time. You can modify existing one. For example, you can move the ACS after it has been placed. Now I will move the ACS to the beam edge. You can also rotate the ACS by a defined angle. I'll rotate it here by 45 degrees. To illustrate to you how the modeling follow the ACS, let me model a beam here. As you see, the beam direction and plane follow the defined ACS. Another method of defining an ACS is defining ACS using 3 points. This one allows you to select 3 points to define the new working plane as shown. Now we'll create a new ACS in the list here and name it as inclined to, then update it to have the ACS saved. To go back to origin, you need to select the base ACS from the list. Another method is to define ACS aligned with view. This one allows you to select a view and it will move the ACS to be aligned with the selected view. To make it more clear, let me select the front view. As you see, the ACS is now parallel to the front plane. This is the opposite of the align view with ACS tool, which rotates the view to be aligned with the predefined ACS. Apply ACS to selected view tool allows you to apply ACS to a specific view. By selecting the tool and the desired ACS from the list, then select the view. This way, the ACS selected is only active in one view, not in all. You can always work with multiple ACS simultaneously by selecting more than one view, each have a different ACS defined. Finally, the Select ACS tool visualizes the predefined ACS in the model. Then you can select the desired one from the model as shown. Now before I finish here, let me show you how the ACS affects the modeling direction and orientation. I will model a beam here in the space. As you see, the beam is modeled inclined following the ACS. If I model a beam, for example, which intersects with the other beam as shown, AECOsim by default follows the inclination or the working plane of the existing beam, not the defined ACS. As you see here, the beam inclination is not following the ACS. If you use the shortcut RC, the ACO draw attention will go back to the defined ACS as shown.